not online are seeing my screen. I guess more information, and you get some insight on how the thinking process is. Yeah. So we left the whole thing. We left the whole thing in. No, not your notebook. Supplier management. We left the whole thing while we were creating our value stream. Now, when we created our value stream last week, I guess. Where is it? Here on the 20th. Okay, so we were here on the current state map. Can you see it? Yeah, so, and what we're gonna do is we're gonna focus on the value stream furthermore. So I will scroll down. We have typed into the details. We have the facilities, and we have some details on the individual elements. Okay, so we have the raw materials, time, and we have the working process. We have the finished goods, and the number of shifts, and so on. So one important question here is the nature of this data. It's allocated in not a manner that you can access easily. Okay. So when you have taken your data in your walk, in your value stream walk, okay, with paper and pen and the camera and so on, nobody is going to have this information in this manner. Okay, so you are going to be walking around the facility. So imagine this is the shop floor. I make a little comic. Imagine this is the shop floor, and you have certain machines distributed, and I don't know, okay? And you see the people walking, and then you have some material around. So the raw material inventory, you are going to measure in time, or because it's let's say you have here your raw material is coming in here. From your supplier, your raw material inventory, you're going to measure in time, because it's the time that you can run your facility with the available material. Okay, it's like your in German it's called Deckung. Okay, so as long as this material is available, you can run your facility. When the material is gone, then you cannot run your facility. So it's the time that you can run your process with. Okay, so in terms, if you want the raw material in number of parts, the only thing you need to do is just the raw material in parts divided by the demand. Okay, because the demand is measured in parts per time. And this is important. Many factories, many facilities, many companies measure their inventory in the amount of time that they are covering their facility with. Okay, let me paint This is more pretty. I don't like it the way it turned out. So you have here one machine with the people, and then you have here other machine with another worker, and so on. Can you hear me well? Is the sound fine, or? Okay, so it looks like it's working. Here we have our raw material inventory. Most of the work of the supplier manager is to make sure that this inventory never goes to zero. Okay, so you can let's say the material flow is going to happen throughout the facility. From the raw materials to the different processes until you go to and you get your finished goods inventory. Finished goods inventory. Okay, so for the raw materials and for the rest of the inventory parts, when you measure the raw material in time measure, you are combining two measurements, let's say the raw materials and the demand, which is giving you a mixed KPI. Okay, the same happens with the work in progress. This is the WIP inventory, okay, along the factory. This is called work in progress. And the same happens with the finished goods. Okay, so work in progress measured in time just gives you the measure of the WIP in parts divided by the demand. As I said, this is an important concept. Finished goods, same. Okay. In parts. Per time. So, is it understandable? And any questions, those online? Okay, doesn't look like it's the case. So this is just one example. Within a facility. Okay. Well, then we can continue with our on page 22, I am, the process, 23, and then after that we get to the so-called quality screen. Okay, what does this mean? Remember, always we are talking to management. Okay, so we are trying to convey information and put that information in a way that our management can understand it. So we have here different facilities, and we see here down quality 2000 ppms, quality 400 ppms, quality 5 ppms. You see number 10, 11, and 12. Okay? Please, if you cannot follow, let me know. Okay, I don't see your faces, so just let me know. So we do the management, the correct way to express this information in a way that management can understand it is the so-called quality screen. And in this manner, you can represent the information that you want to convey in a very simple manner. What ppm means is clear. You know, yes, parts per million. Is it clear for everyone? Maybe those that didn't attend previous classes with me don't know. Christian, you know. Katerina, you know what ppm means? You don't know. So please tell me. Okay, I cannot see you, so I cannot read your thoughts. So ppm means parts per million. Okay, this is the if you produce, or if we produce 1 million parts, how many defects do we have? Okay, defect parts per million. This is the meaning. Okay, so if you produce, let's say, imagine you would produce 1,000 pieces, 1,000 parts per day, and you would have 30 defects. You would have a ppm of 1,000, 1 million divided by 1,000 times 30. Okay, so you would have 30,000 ppm. Okay. Parts per million. It's a way to represent the defects in a facility. Is it clear, Katarina? Is it clear, everyone? Okay, so I guess yes. If no, let me know. Okay. So we copy what we have. Michigan. To gamma, then gamma to beta, then beta to alpha, and then alpha to alpha VC. Okay, so and here we have let's say over 10,000. Then we encounter 2000. Then what do we have? 2000 here. Then 400. Okay, this is here, here, 400, which should be somewhere around here, and 5, which is almost nothing. Okay. So what does this screen is telling us in the value stream? Can somebody tell me? Can somebody tell me? What does this screen is telling us? Okay, the important part of the whole exercise is the interpretation. Okay, you need to think like a manager. What is this telling us? Yeah.
It shows in which courses of the value streams there are the most quality problems.
It shows where we have most quality problems. Very good. And where do we have the most quality problems?
The process with the highest PPMs.
PPMs?
In this case, it's the process from Michigan to Gamma.
Okay, and why do you think that we have the process Michigan to Gamma with the most quality? Is because they're very bad issues. Why is it? Looking at this picture, the current state, why is it that in this relationship we have the most number or the biggest number of parts per million? And here in this relationship we almost have nothing. So this is the important question. Please.
The later we are in the value stream, the parts that are not alright are already excluded from the value process. So at the end, there are always usually less parts that are not alright.
Yeah, that's very good. That can you repeat it for the record?
Okay,
No, so please come.
So from which point on?
The later you are in the value stream.
Alright, so the later you are in the value stream, there are already the parts that are not alright taken out from the value stream. So that leads usually to the fact that at the end there are less parts that are not alright.
Thank you. Vielen Dank. Could you hear? Yes. So it's very good. So the later you are in the value stream, the better your quality gets. Okay. And the reason is, let me paint it prettier. The reason is an important fact. Okay. So if we describe D as the distance from the beginning in number of steps, This is D. This is the number of steps that we take from one process to the next, okay? There is a dk, or d big, okay, distance. There is a dk with d of the defects. So the defects, you can say that the defects usually are some sort of constant, let's say a factor k, constant, divided by d. Okay? This is the way it usually works. Okay? The equation yields something like this. If these are the ppm and this is d, we get some curve like this. Okay? And this is usually the case. Now I ask you again why this is the case. Okay, we know, we have learned yet now that the later we are in the value stream, the worse, the better it gets with quality. But what is the reason in the process? Why is it? Can somebody tell me? Anna, Fabian, can you tell me? Can you tell me? Why the later we are in the value stream? Katerina, Christian, Habil, can you tell me why? Because this is the kind of things that I am going to be interested in the exam. Okay. This is explained in the book, and you need to go deeper into the whole book. Well, the reason why. So no answer, Christian, Katerina, or Abel, or somebody else. No answer. Okay. The reason why. By now this should be clear. Why we find a d minus 1 dk in the defects along the value stream is that we have, on the one hand, quality feedback loops. So the people from, let's say, beta wipers are telling the people downstream whenever they find a mistake. Okay, quality feedback loops, which are nothing less than a quality management information flow. So whenever I find a mistake in the process, I tell my supplier, hey, I have a problem, please fix it. And this goes along the value stream. Okay, makes sense? So if I get some parts that are wrong or they're broken or so, I tell my supplier, hey, you send me a wrong part or something like that. Is that cool? The second reason, and it's maybe a more important reason, is work in progress. because work in progress inventory leads to a process variability reduction when implemented in pool. What pool means, you should know by now. Is clear what is meant by pool process? Yes or no? No? Don't remember? Okay, this should be, by now, should be second nature. You should remember something like this. We saw this in the first semester, production. Fabian is nodding. Do you remember, or what is this? No? Kanban, okay. Kanban, supermarket. You remember how to calculate the supermarket? No? Those online, do you remember? No? Okay, please look at it at some point. Okay, I will not get into that now, but this is important. So if you drive a whip through pool process, what you get is something very interesting called the bullwhip, excuse me, the Goodhart's law. No, not Goodhart's law. Little's law. Little's law. You remember Little's law? Somebody tell me what Little's law was? Little's law is the work in progress measured in parts divided by the output of the process measured in parts per time unit. So when we run a whip with pool, what we are doing is we are avoiding the bullwhip effect. Can somebody tell me what is the bullwhip effect? Bullwhip. So we are avoiding the increase of variability throughout the value stream. Okay, this kind of stuff you should be knowing like by heart. Okay, this is very important for your job in the future. If you don't have these concepts like in the top of your tongue, then make sure you get familiar with them. Variability increases when we go farther from customer. Is this clear, or have you seen the bullwhip effect before? Yes, right? Those online too, or is it something new? Something that you know? Katerina, do you know the bullwhip effect? Okay. Well, anyway, as you see, so here we can clearly appreciate in this quality screen that we have in reality a bullwhip effect. Okay, why? Because the parts per million are increasing exponentially when we go back. So we observe in the quality screen that we have a bullwhip effect and we can therefore infer that we do not have a pull process in place. Okay? Do you follow me, or do I need to repeat something? Can you follow? Yes? Yes? Those online, can you follow? Katrina, Christian, Abel. I guess only 3 online. Yeah. Okay, so that's what we observe. So we don't have a pull process, and this means that we have what? What do we have if we don't have pull? Do you remember what was the other option? Christian, Katerina? You remember the definition of pull? Okay, definition of pull is to produce taking into consideration the customer's demand. Definition of push is to produce without taking into consideration customer's demand. Okay, so we can infer that we have a push process that does not take customer demand into consideration. Okay, neglecting customer demand means neglecting customer demand means worse quality. Can somebody tell me what the reason for this is? why we get less quality if we lose sight of the customer demand. Somebody online? No? Okay, the reason why is because of, again, the quality feedback loops. And a little slow. Okay, because if we have, let's say, inventory between the processes, if little slow says the that the wait, little slow, let me write it correctly. This means that lead time is die Durchlaufzeit in German, is WIP divided by output. That's little slow. If the WIP increases, what is it going to happen? If here I have more inventory, then when I discover a mistake, when the customer discovers a mistake and gives feedback, hey, I have a wrong part, it will take longer. So the quality feedback loop takes longer. And because it takes longer to fix the problem, the quality takes longer to fix. This is logical, right? Can you follow? If I have more parts between this process and this process, here, if I increase the inventory, then if the customer discovers a mistake, it gives the feedback, hey, I have a wrong part, later, right? Es dauert länger, bis ich den Feedback gebe. Und das heißt, weil es länger dauert, because it takes longer, then the quality takes longer to fix. Which means that the PPMs go up. Okay? So this is super important. This is actually the basics of process management. We saw this in the first semester, so please make sure you look at that at some point in the next couple days, okay? Any questions so far? This is explained in the book. If you want to read it, I strongly recommend that you prepare this carefully, okay? Any questions so far? So we can combine our quality screen with a so-called delivery screen, okay, which is going to take the number of defective deliveries. It's also here. No, it's not. It's not here. This is something new. And we can do that by combining that into a, let's say, new access, okay, delivery screen. we can say we have, let's say 10, 5, and this is the number of, or the percentage, better, percentage of defective deliveries. Okay. So, and as is stated there, we have here some something around 8. We have here something around 6. We have here something around 2 and 1. Okay. So now what do we find? Can you give me a law for this? A law means a math representation. We would say, if we were in statistics, we would need a linear or a polynomial regression of this. We have done also this before. In theory, I could give you the 4 points and tell you, give me the linear regression that describes this data. Okay? And this should be done easily by you by now. Okay, so here we have that delivery, percentage of delivery, or how do you say, defective deliveries. What did I use up there? Defective deliveries, the percentage of defective deliveries is some sort of constant, positive constant times the distance. Okay? So it goes down, but it goes down linearly, and it doesn't go down like before in a curve. Exponentially, it goes down linearly. So why is this the case? Why is there a multiplication effect that we have seen before? Here we have this distance in the denominator. Here we have this distance in the numerator. Why? Can somebody tell me? Okay, well, it's in the book. Please think about it. Why? Okay. You can come back to me if you have one solution, or if you think you found a solution. You can come back to me and we can discuss. And somehow I'm trying you to get involved, but not much is coming. Okay, so now we are going to represent the whole value stream. This is represented on page 20 something. 26. Okay, so I'm not going to go to the last detail, but let's say what we are here, what we represent here we go back to our value stream here, and then we say, well, what do we have? We have material flow running. Let me paint it with this color. From Alpha Motors assembly to Alpha Distribution Center, DC. I guess here somewhere I wrote VC and it should be DC. So we have here our distribution center being delivered, let's say once every day. On a railroad, once a day. We look at the ship batching, so it's going to be important later on. We do that with the appropriate color. Sorry, this is wrong. Should be from here. So this is done once a day. Per train. And here we have 500 miles. We have a seat batch of 1 unit train. Okay, so we always send our unit is the train. And we are going to have delivered 960 vehicles. And we have defects as of 1%, which is what we described in our defective parts. This is 1%. Let me paint it in blue so that you can follow 1%, and here also 1%. You see, we're creating a visual of the information represented. Okay? So far, good. Next is the relationship between Alpha Motors crossdock and Alpha Motors assembly. Okay, so this relationship. And this is taking I guess I don't like it. Let me do it somehow different. This is being done in 2 ways. We have our truck, okay, who's delivering once a day. Our trains are also once, how often? Once a day here. We have the trucks once a day, and we must air freight some material also twice a year, but we don't represent that yet. So here our batch is here, duplicate. Our batch is going to be about 2,000 miles per truck from Texas to New Jersey. $2,000. The shipping batch. Do you know what the shipping batch is? Bestellmenge. Okay. 6 pallets, and we have a defective percentage of 3%. Okay. Any questions? Guess not. The next step, again, is that we have also a delivery. Also, it's taking part once every day. And here we're talking about 800 miles. The shipping batch is 6 pallets. And we have the effective also of 3%. So we go on. That's from the Harlingen to El Paso, and we go on with the thing, and here from Beta Wipers assembly to the Beta Wipers crossdock. We have also every day with truck. And here we only have 100 miles. The shipping batch is 6 pallets. And we have the effective of 3%. From the warehouse to the assembly again. And now it comes. We have a delivery 5 times a year. What does this tell us? From Texas to Reynosa. We deliver only 5 times a year. What happens then? You can see it in the screen, so what happens? What happens with quality when you increase the or decrease the frequency from once a day to 5 times a year? Because 5 times a year is only one special delivery. Okay. What happens with quality here and why? Shipping batch, 12 pallets. Defects is now 6%. Here, the shipping batch was 6 pallets and defects was 3%, and here the shipping batch is 12, and here we have double. So what happens? What do you reckon here? Was ist hier zu beobachten? If we increase the shipping batch, the size of the material that we deliver, then the defects increase linearly. You see? We double the shipping batch, the defects double. This is what we see in this curve here. We double the shipping batch, so we are doubling our quality in the defective deliveries. Okay? Do you understand this? Does it make sense? Everyone online, does it make sense? Can you please answer the question, yes, or do you need more explanation? Hello? Okay, no feedback. Sometimes I don't know if you are there or you're just drinking coffee, or I don't know. It's interesting. Yes? Happy? Yeah, good. Okay, thank you. Again, can you ask in German? I didn't understand. Also wir nehmen jetzt anstatt eine Lieferung mit 6 Gitterboxen, jede Lieferung hat 12 Gitterboxen, also das Doppelte, okay? Und das bedeutet, dass die prozentuale Defect Rate sich verdoppelt. in the delivery. Okay? Das ist zu erwarten, genau. Also wenn wir hier ein anderes Lieferverhalten hätten, dann hätten wir hier eine Steigerung. Okay? Alles klar. Gut. Dann from beta, from gamma stamping to the warehouse, we have also a delivery. Sometimes it doesn't work for some reason. So we have a delivery here. And this delivery has following information. 1,500 miles and a shipping batch of 35 pallets and a defect rate of 6%. So why is this? That the effect is now not linear. So there are several components here. Here, think about, we have a daily delivery, and here we have a daily delivery, so we can compare, but here we have a twice a week delivery. So it's less often, and that's why we cannot compare this with this. Okay? That's the reason. In the end, we have our latest relationship that we look at today. So, excuse me. Duplicate here and here. And we have, of course, our data. We have our data with 500 miles, a shipping batch of 72 coils, and a defective rate of 8%. Okay, and here we deliver twice a week. So you see here also an increase. In the defective rate part. Okay. So one exercise I'm going to give you for tomorrow is to think about this. Okay, we will look at this tomorrow, but please look at it now. Okay, in the next couple hours. These lines below on page 26 and 27, you have some timelines being displayed. Please think about why you have these numbers there. Okay? We will do the numbers tomorrow, but I would like you to think about it because this is the kind of the trickiest part in the whole thing. Okay? So any questions so far? We have described the number of stations and the material flow. Okay? We don't have the information flow yet. We will do that tomorrow. Any questions, please? Material flow. Oh, sorry. No, I don't like it there, so I'm going to need that later on. Put it up. I put the legend up, okay? So this is the material flow. And we will look at this later on. The information flow we will look at tomorrow. Okay, please look at page 26 and 27 for tomorrow, and look at the lines below this information. Okay? Any questions? So I guess I'll send you the PDF in a minute, and you can access the YouTube in a couple hours, I guess. Okay. Hope you can hear me. Can you hear me? Yes, okay. Well, yeah, so we continue with the case study as discussed, and on the lower part of the diagram of the case study, we will print two timelines. Okay, one it's concerned with non-value adding, and one is concerned with the value adding processes. Okay, so the way to visualize this is we have one line for value adding, and one line for non-value adding. And this is done in a way that the information is already known. Okay, so we have this from the data that we have taken, and well, the way this is described here is a little bit different. Wait, they don't use value adding and non-value adding lines. They use two lines. Okay. Well, we will use two colors, one for non-value adding and one for value adding. And here the times are going to be like this. Okay, so we have here on the shipping line here, as you saw yesterday, here 1 day shipping. Okay, so we write here 1 day. Here, put it here, 1 day. All the units are in days, so unless otherwise stated, 1 day. Of which 0.5 are in planned transport time. Okay. Then we go to the Alpha Motors assembly, and we have in planned time 2.8 days. Of which 120 seconds are value adding. Okay, this is the meaning of it. Okay, 2,8 Tage nicht wertschöpfend im Werk und davon sind es 120 Tage, 120 Sekunden wertschöpfend. Where do we get these 2.8 days from? Well, we know that our customer wants 960 pieces per day. Okay. And we know we have this much inventory. 50 hours, 2 hours, 14 hours. Okay. So this information combined with the information that is below, 11 days, and in plant 2 days, is the information that we are going to be combining. Okay, these 11 days is the time that we can cover with our inventory. Okay. So we continue with the next shipping. The next shipping, it's 1 day again. And the Alpha Motors dock takes also, I'm going to put it at the same level, 1 day. The Alpha Motors dock is here 1 day. The shipping batch is 1 day. Then the Alpha Motors is 0.5 days. And below 4 days. Then the next shipping batch is going to be 4 days. 1 day again. Four days. And so on. Okay, so in Harlington, it takes 0.5. And here 4 days again. And so on and so forth. So here the issue, okay. Well, I guess this is these are not days. There's a number of steps. I'm not so interested in the number of steps. I'm more interested in the days. So I'm just gonna put that away. So in beta wipers, I have so here I have still the this takes 0.25 days, and here I have in beta wipers I have 4.6 days inventory, and 30 seconds value item process. Why do we know that it's 4.6 days? Because this time, okay, it's giving us 4.6 days. Yeah, so we continue with the beta wipers warehouse. It's 2 days. and then gamma stamping 20.6 days, and value adding 3,131 seconds. The next one is 0.3 days, and that's about it. Okay. Here I have still 1 day. So we add up all the information. We take the sum of all non-value adding divided by total time or better said, I mean, you can measure this in different ways, but the sum of value adding activity or time divided by the total time equals the sum of value adding divided by the sum of non-value adding plus sum of value adding. Okay, and in this case this delivers a KPI. Wait, I have it. So the total lead time is 44.3 days. Take my Taschenrechner. 44.3 days multiplied by the total time of non-value adding is 0.03544 days if you add up all the seconds. Okay, so this means that we have a 0.08% ratio value adding versus total. Value adding. And this KPI is super important when you deal with a supplier. Ich wiederhole in German, in Deutsch. Ich komme echt durcheinander mit dem. Ich wiederhole, wir machen hier etwas Wichtiges. Okay? Wir addieren alle wertschöpfenden Tätigkeiten und teilen das durch die gesamte Durchlaufzeit. Okay, also wir addieren alle wertschöpfenden Tätigkeiten und teilen das durch die gesamte Durchlaufzeit. Dieses Ratio ist wichtig, um einen Lieferant zu bewerten. Okay, so kann man Lieferanten bewerten und auch Entscheidungen treffen als Supplier Manager. So with this KPI, this is a very important, let me paint here a little sign. I paint usually this comic whenever we find something important. Kleine Klugscheißer. Okay, so this is super important KPI to measure the performance of suppliers. Is it understood? I need your feedback, so please please tell me if you have any. This is super important. Okay, so this is going to be subject to exam, but not only for the exam. It's important for your life if you are going to be making business in the industry. This is the way you measure your suppliers. Okay. So please give me feedback. Is it okay? Is it understood? You need something else as explanation? Katerina, you're cool. Okay. Feel free to put your microphone on and ask. Sollte ich es auf Deutsch wiederholen? Ich möchte nicht weitermachen, wenn es nicht klar ist. The days, okay, so you know in one day, okay, let me paint here. Who did ask? Janet? Also Janet, schau mal, pass auf, hier, okay, so eine kleine Notiz. Ein Tag equals 24 hours, okay, equals 24 times 60 minutes, equals 24 times 60 seconds. Okay? So in einem Tag hast du, glaube ich, 1440 Minuten und 86.000, keine Ahnung. Lass mich kurz, ich weiß nicht mehr, 86.400 Sekunden. Okay? Das ist der volle Tag. Dann kannst du sagen, ich habe nur 2 Shifts, okay? So, das sind 16 Stunden. Dann musst du anstatt die 24 Stunden die 16 Stunden bewerten. Okay? Das ist je nachdem, wie viel Zeit zur Verfügung steht. Okay? Aber normalerweise ein Tag hat komplett diese Zeit. Okay? Das ist klar. Oder? Gut, dann gehst du her, hier, und du sagst, okay, hier habe ich 2 Shifts, okay? Und ich arbeite 5 Tage. Also, du weißt, wie viel Zeit gearbeitet wird. Richtig? Der API spielt jetzt noch keine Rolle. Das ist für später. Okay. Ja, und dann die Sekunden umrechnen auf Tage ist klar, oder? Das kann man relativ schnell machen. Okay, gut. All right. Any questions? Please ask. This is super important. Okay, I don't want to. I don't want to hear later I didn't understand, or if I ask this in the exam, I want you to tell me, and I don't know. So please ask now. Make it a little bit more pretty. And yeah. So no questions. Can I continue? I need some space here, so I'm going to paint this again. So what have we done so far? And this is always the roadmap. What have we done so far? We have taken first some planes. Okay, we have visited our facility. We have done the value stream. We went and see. So we gather some data. Then we have put all the process steps at a certain level of abstraction. Okay. And then after that, we have put all the material flows. Okay. What do we do next? What do we do next? So, as I said, we first go and see. This is the first step. Then we make the process steps. Then we go and put the material flow. The next step, the next natural step is what? Well, the information flow, okay? The information flow. And this is exactly what we do now. I'm going to paint it now with a different color. Or wait, to have it similar. I will paint it in blue now. Always remember, for your future life in business, information flow leads material flow. So information leads material, not the other way around. Anyone in the world can move material around effectively somehow, but it is very difficult, way more difficult to move information effectively. The reason is that information cannot be seen, okay? So our most important concern as supplier managers is to understand the information flow. Ich wiederhole auf Deutsch, weil es so wichtig ist. Materialfluss wird von dem Informationsfluss gesteuert und nicht umgekehrt. Das ist der Grund, warum Digitalisierung so entscheidend wichtig ist und warum ihr dringend notwendig habt, mehr zu erfahren über Informationsflussprozesse. Okay? Informationsfluss ist steuert Material, nicht umgekehrt. Did you understand this concept? This is super important again to get this right and to get this straight. Information flow beats always material flow. Okay? So please make sure you get that straight. Because mapping information flow is way more difficult because you cannot see information. Usually it's just digital, okay? So Alpha headquarters, production control. The distribution center sends some production control orders and they have an inventory in information of 14 days. Okay, then weekly, this information is broken down into small batches. On a weekly basis, I paint once a week, okay? Once a week. And we have some sort of MRP system, which you should know by now what it is. And this MRP system goes to the assembly. Okay, on a daily basis. The assembly sends back whatever they have produced in the system. This happens automatically, of course. Okay, it's a sort of e-Kanban or something like that. Okay, so this HR is in Michigan, as you can see. So what is the big problem that you see here? Big issue, and something that you will need to be dealing with when you are in business. What is the biggest issue here? If you have your material control plan in Michigan and your facility is in New Jersey or in Ohio or somewhere else, what is the biggest issue here? Ich wiederhole in Deutsch. Stellt euch vor, ihr habt eine Fabrik in Hamburg und ihr seid in Stuttgart und versucht die Fabrik zu planen, auszulasten mit Aufträgen. Was ist los? Wo ist das Problem? Komm. Wo ist das Problem? Seid ihr da? Janet, wo ist das Problem? Oder Burko oder Christian, Fabian, Dominik. Yes. Yes, you lose that. So you have what happens. Let me paint a little picture. So, very good, Christian. So let me paint a little picture here. Maybe with this example it becomes clear. Okay. So imagine this is a hotel. Okay. You are on the last floor, on the 10th floor, and you come to the hotel and you want to have a shower, but the heating of the water happens in the basement. So this is Christian trying to have a shower. Okay. So Christian, stay with me, please. So you turn on the hot water. Okay. So the first step is you turn hot water. Then a signal goes all the way to hot water. So you do something physical. Then a signal goes all the way to the heater. Okay. The heater starts working. And then it starts sending a signal goes to the heater turns on, heater on. So you start producing hot water. But it takes, I don't know, 2 minutes for the water to come up. Okay? All this time, 2 minutes. All this time, what has happened? Between turning the water hot, you have cold water. So what happened? You're in the shower, you're naked, you're having a shower, you want to have hot water, but it only gets cold. You only get cold water. What happens? What do you do? What is the... You waste water, but what happens with you try to turn it hotter, right? Because you think it's not working. Okay, so because there is a lag between this turning hot water and the minutes it takes to get there. So basically you can represent it like this. There is some sort of process and there is a feedback in the process that turns in automatisierungstechnik is called a regla. Okay, there's a feedback loop, and because this feedback loop takes some time, the process gets always out of control. Okay, so you can in an ideal world, if this would be real, you would never get a pleasant shower. So a delay in information flow is the number one reason why processes do not work. Okay. Number one source of variability. Always think of a hotel and trying to have a shower. I don't know if you had the experience. I've had it some quite often. Okay. So the delay in the information flow is the number one reason why things go south. Does it make sense? Yes, you're cool. Okay, so what Christian said, intuitively, Cleveland to Ohio, if something happens in Cleveland, people in Michigan will take some time to react, and as a result, things will not work properly. Okay? So this is maybe one of the reasons why things are going like they're going, and why they are, we have a bullwhip effect and stuff like that. So here we have another box. This is the plant production control, also MRP. Sorry, MRP in Harlingen, Texas, and what they're doing is they're sending the information to the supplier daily and weekly. Okay, and they also have a beta production control. Beta headquarters production control. We have this in Cleveland. Ohio, Michigan. And here we have an inventory of 6 days. They communicate once a week. Okay. And well, I'm not representing all the information, but because you have it in the data set or in the PDF, you can look at more detail. I'm just trying to represent the most important parts. You get also an information flow every week. Gamma headquarters, production control. Here you have 14 days of, what is this 14 days mean? This is in Buffalo, New York. What does these 14 days mean? And you have your gamma MRP. In New York again, you communicate, and these guys are communicating with the stamping. Okay. And these guys are communicating also with the supplier. What does these 14 days mean? All this. Somebody tell me. Steffen, Katharina, somebody tell me please. Christian, Janet, Fabian, Dominik, vielleicht. Okay, this is material. This is information inventory. Okay. So this here is information inventory. Okay. All right. So could you follow so far? Paint it again. Could you follow so far? Okay. So now we deliver, okay, now we have a current map, okay? So we have a lot of information, but if we give this to management, they will say, what the fuck are you doing with us, okay? So they will not, probably not pay a lot of attention. Usually managers are busy. So what we do is we give them a management summary. Okay. So, and this is what is expected from you as supplier managers, that after doing all this analysis, you prepare, excuse me, a current state management summary. Okay. Not know? So the first thing we do is we represent the total lead time, gesamte Durchlaufzeit, and this is 44.3 days. Okay. If some of these numbers are not clear, just let me know. Then we represent the percentage value percentage time, which is the value creating to total time. We have seen this is 0.008%. You can also represent the number of steps. I'm not so much interested in the number of steps. You can represent the inventory turns. Five. What is an inventory turn? Somebody can tell me? Can somebody tell me? So inventory turn, or in German Lagerumschlaghäufigkeit. Folgendes. We have the mean value of inventory. Okay. The average of the inventory levels. And we have a revenue, in German Umsatz. Okay, so the inventory turns equals the yearly revenue divided by, well, this is average inventory divided by the average inventory. This is the math. What does it mean? How often we replenish, how often do we renew our inventory? Okay. Do we want a high or a low inventory turnover? You move your inventory faster. What do you need to have a high inventory turnover? So if we want high inventory turnover, what do we want from this formula? So we want a high revenue or a low inventory. Okay, and because the revenue comes from the customer and the price, and that's usually not very flexible, we can work on the flexibility, and this is where our EPI is coming from. Okay, we want flexibility towards the customer. Does it make sense to you, or am I talking just gibberish? I mean, I'm mixing a lot of concepts, but this is an advanced course, okay? So you're in the last semester, so all this should be at least familiar. If not, please let me know. Otherwise, it's kind of frustrating. Does it make sense, please? Yes. Okay. So if somebody wants to ask, just interrupt me anytime. Okay. So the next. Thank you, Christian. The next is the quality screen. Okay. We have seen that we have 400 quality screen. So we have 400 ppms. Those are the defects at the downstream end over defects at the upstream end. Defects downstream divided by the defects upstream. So the delivery screen it's also again 8. Okay, this comes from 10,000 divided by 5. 10,000 divided by 5, or what was it? What's the level here? 10,000 divided by, how many ppm did we have in the end? 5, yeah. Is it only taking the pedal wipers? 1 second, please. It's showing 400 there. No. Is it showing 400? It's 2,000 divided by 5, right? This is 2,000 divided by 5. This is the here. Quality at gamma stamping divided by the quality at alpha motors. Assembly. So then we have 8 delivery screen. Which is the percentage of defective shipments at downstream, divided by defective shipment upstream. Okay, and this is again number of defective shipments, this number divided by this number. Okay, which is just 8 divided by 1, I guess. And yeah, so we have also the product travel distance. $5,300 miles for a wiper, okay? That is only produced in 2 countries. 5,300 miles, which is this is a CO2 related issue. So climate change, it will become increasingly more important. Okay? So Nachhaltigkeit und Sustainability and the whole game there. So are you cool so far? Yes. Please. Please ask questions. No questions? I'm going to share one. Okay. So what you see now is going to insert one picture. Okay. Because I don't want to paint it. It's just too long. The next step is to describe the so-called demand amplification screen. Okay, you can see the steps to do it in the PDF, in the case study. But this is the demand amplification screen is a very powerful tool to describe a lot of information in just one image. Okay, what is it describing here? What are we dealing with here? Well, what we have here is following. Okay, let's take we see a bunch of lines, but let's take alpha production. Okay, we see here an amplification of plus minus 5%, or let's take beta production. We have an amplification of okay. So what is this telling us, guys? We can represent this in a different way, okay? A more compact way, let's say. And maybe then it's easier to understand. What is called the demand amplification screen. Just as we had before, we paint a square. This kind of diagrams are very, very often, at least in the American business world. I don't know if you're going to work in America or with Americans, but if you do that, it's something very useful. So we have different steps in the process: gamma order, gamma production, beta order, beta production, alpha order, and alpha production. Okay, and you see that the percentage of variation, how much it goes up from the mean value. Okay, how much the curve goes up from the mean value. What does this mean from statistics? Somebody tell me. You will get an espresso for me if you answer. What does this mean from statistics? Mean value, and what else do we have when we have a distribution like this? Okay, too late. The espresso is gone. I'll drink it alone. Too bad. We have a standard deviation, right? Whenever you have a normal, you have a mean value and you have a standard deviation, right? Or not? Hello? The way you can paint it is like this. So the blue curve and the green curve takes, okay, well, I guess not so pretty. Which process is more accurate, the green or the blue? Hey guys, please get active, okay? Hello? Which process is better? The blue one is better, but why? Less variability in the process. Very good. So 35. If we represent that in just one screen, we can go and say our demand amplification at gamma order is I don't know, over 35. Then we have the gamma production over 25. Then we have the beta order over 20. Then we have the beta production over 15. Then we have the alpha order over 10. And then we have the alpha production. So what do we have, guys? What is it that we're having? Here. What do you see? What do you see? Yes, the variability is reducing along the varistream. We saw that yesterday with the inventory. So variability in the information flow is reducing when we approach the customer, which means that this is the same as saying the variability is increasing when we go farther from the customer. What is the name of this for a supplier manager? This is called the bullwhip effect. Okay, again, let me paint here a little comic to make sure that this is super important. So whenever you're dealing with a process, make sure you paint. The first thing you do, if you have only one thing to do, is to paint the variability screen, the demand amplification screen. Okay, this will give you a lot of information about what is going on in the process. A lot. Okay, variability equals standard deviation which means this. Okay, if you thought you were done with statistics after passing the exam, think again. Okay, probably the most important lecture is statistics for you, whether you like it or not. So does it make sense? Questions, please. So we have a demand amplification index that we can add here. We can add here a demand amplification index, rectangle. Seven, okay, demand amplification index, which is just the ratio, the percentage of change in demand downstream and upstream. Okay, percentage of change demand upstream. And that would be your current state management summary. Okay, this. Just dividing this number by this number. 35 divided by 5 is the demand amplification index. Good. Well, any questions? So as I said yesterday, this case study is going to be, I guess, the cornerstone of the lecture. Please make sure you get deep dive into it. Okay. If you have any questions, just let me know. anytime, contact me, okay?